Okay, this is day 2 of the process of beginning to overhaul and repair this garage found SB220, and I got out the notes that I made when I started on this. You can see that I started on this thing in March of 2016. That's 7 years ago that I got this thing and I brought it home, and I did this. I did the preliminary cleaning on it and checked to see how it was wired. Cleaned it with hot soap and water and isopropyl alcohol, and went through here and made all these marks in here where there are faults to be corrected, and I made pages and pages of lists. So now what I'm doing is I'm starting to work my way down the list, and the first thing I'm looking at is this coil. This is a 24 volt relay instead of the 120 volt relay that's supposed to be in here, and this little terminal strip has a little full wave rectifier in a package and a couple of filter caps. I don't see that it's connected to anything, but I think it was supposed to steal power out of the off a filament circuit, although it may have been outboard. But anyway, I'm about to take this out. So that's on the checklist here. I'm going to remove the relay, I'm going to remove the non-standard wiring, and I'm going to check those things off of the list. The next thing up here is I just took and put an ohm meter on this coax here. This is the output that carries a kW of RF power, and I just checked that for continuity and checked it to ground. I found about 107K to ground, but I think that's due to the resistors and diode for the relative power metering circuit. So I'm thinking about whether or not I'm going to replace this coax. It probably will, but it's not shorted and doesn't seem to have any terrible leakage to ground, so we might try to live with it. I've got to do the same thing with this this other coax here. This is the ALC circuit up here, and if you flip the page over here, I just call it terminal strip. At the time, I guess I didn't know that was the ALC circuit. So it's one cap that's an old paper cap, and another one that looks like it might be newer, but I think I'll replace it with something more modern than that, because the whole thing is ugly, and all these wires have to be resoldered. And there's 100 and I don't know, 1.5K 1500 ohm resistor that's down here on the bottom of the chassis and wired to that. So I'll yank that out and make notes of it, and you know, just start working my way through the list. Okay, I'm just going to go to work on this amplifier. And I guess you can see what you can see. Maybe we'll speed it up and see what happens. So all the discarded parts are going up into a tray here, and I'll deal with them later, like the diode metering board and the what do you call it, capacitor block. I'll rebuild. Too good to throw away. Nothing wrong with the original designs. Just put some modern parts in there. All the good. Now, what was I going to unsolder? Something, I can't remember what. Glasses on, no wonder I can't see anything. Get my magnifying glasses, that'll help a lot. Usually the beginning of any radio overhaul is removing the crap, stuff that wasn't designed in there. you know, unless it's a known real improvement, something that's documented and maybe maybe approved by the factory or the people who made the thing in the first place. Heathkit certainly has authorized some revisions to radios over the years, and no reason not to incorporate a factory designed upgrade. We may well change this and go to directly grounded grids on this thing. I don't know. I got to look into that more. And but it may eliminate some possibility of parasitics on 10 meters or something. I don't know. We'll find out about it. But all this undocumented stuff is just a hindrance. You don't know what it is, what it does, what it was intended to do, whether it was done right, you know, or whether it was just stupid in the first place. So much crud on the internet. This is a really nice relay. And yeah, Potter and Brumfield, 10 amp contacts. .24 volt DC coil. It's a very nice relay. I'm not saying we couldn't use this, but the way it was done was bogus. And went to a lot of trouble to put that glue in there, and it didn't adhere with the darn. Well, that's kind of dumb. I think it might have been epoxy or something, but it didn't. Well, I managed to forget to plug in the camera, so the battery went dead. So I have no idea how much we lost here. But over here on this terminal strip, this is all the ALC circuit. And we found that two resistors had been replaced. Supposed to be 2200 ohms and I think 27K. And we found 33K and 22K. And the diode that was here was open. It was no good at all. And we took out two filter capacitors, and this was one ancient old paper capacitor, and the other, the guy had tried to replace an electrolytic with some really old dried out thing, and you could look at the end and see the end was all broken and no good, and he'd used that as a replacement, so we took that out. So basically we've got no components on this terminal strip at all. Also the terminal strip is extremely loose on its mounting, so I'll see what I can do about that. Either I've got to upset that rivet or put some glue on it, something. But anyway, so that whole ALC circuit basically is non-existent. There were wires that were, this wire here that goes down to the I don't know if it's, I guess it's either the ALC or the relay. I think it's the ALC. Was jammed underneath between the chassis and this circuit breaker, and you know, running down here. So I just got it in the loom where it ought to be, and these the ends of these coax was this one was just down to a little tiny whisker of a wire, and all dirty and messed up, and the insulation all messed up from heat. So I'm just cleaning these and retinning them so that they're I can reconnect them. This wire here that goes to the center tap for the transmitter was also all goofy. Resoldering these connections where there was just gobs and gobs and gobs of solder and really ugly connections, and just resoldering them so that they're decent. And so that's just what I'm doing, is kind of going through here, trimming off excess lead length, resoldering poorly made connections, as some of these connections have got enough solder on them to do an entire Heathkit just on one connection. So we're getting rid of some of that crud. A lot of terminal strips have a bunch of old leads from old devices that is still on there, and just like this one here, got that giant gob of solder to you know, hold on 1.02 capacitor. You just don't need all that crud. So just trying to clean it up because it's, you know, it's just too ugly for words. And some of these, oh, this is a good classy 0.022. I've used a lot of these capacitors in radios, usually in audio circuits, not as bypass capacitors, but got so much excess solder here that it's getting down inside the RCA connector. So you can't put a plug in there with a blob of solder running down the middle of the connector. It's crazy. So I usually use just ceramics for this bypassing and not these mylar caps. But I'm not quite sure. Probably the only thing he had of the right value. But just a little peculiar for that application. And got enough lead length here to wire the whole amplifier. So that's just what we're doing. Removing crud. And it's a good thing that I didn't take it for granted that these new resistors in here were the right value, because they were utterly wrong. They were off by a factor of 10. You know, 22K instead of 2200. 10 times more. And, you know, a diode that's just bad, all you got to do is put a no meter on it to find out that the diode is bad. I don't know what to think about this corona dope he's got on here. I don't think I can get it off. So I either have to leave it on there and live with it, or replace the coax, and it may prove to be a smart idea to replace the coax. We'll see. I sure don't like seeing this on here. You know, if you've got arcing problems in your amplifier, and it's on your transmission line, chances are that corona dope is not what you need. It's not going to cure the problem, because the problem is elsewhere. It's something else going on, and it's just ignorant. That's all it is. Just plain ignorant. Well, sometimes you run across a radio where every attempt the guy makes to fix something makes it worse. And it seems like there's several ways you can make it worse. You can make it worse by putting the wrong component in there, the wrong value. You can make it worse with really bad craftsmanship. And you can make it worse with bad ideas. And it would seem that this guy has done all three in various spots. Now it's hard to, you know, after the fact to figure out what the guy was doing. Why are there wrong values in the ALC circuit? Was he doing that to accommodate the needs of some modern solid-state radio? That's possible. Was he doing it because he couldn't use the color code properly and couldn't tell the difference between 2200 ohms and 22K? This is also quite possible. So in this case I've got grid bypass capacitors on here that are so poorly done that there's no way I'm going to trust them. He's cut something off, put something else on, and put two things on where there was one. And, you know, I'm just not going to trust that crap. Oh dear, oh dear. different wires. And we need one short one. How hard was that? No idea why this is all bent out of shape and deformed like this. This is an RF transmission line. And kind of like to have it at a constant distance off the chassis. Alright. Alright, so now do some bookkeeping. Okay, so here in the book I'm making a note on the about the ALC circuit. I need to replace 2 resistors, 2 capacitors, 1 diode, and when those are done I'll make a check mark out here. So fix poor connections, AC primary, that's done. RF, we're working on that. Haven't done the grounds, haven't done the switches, haven't done the panel connections. Wiring condition and lead dress, we're working on it. So what else? Antenna relay. Check added bypass caps are going to replace 0.02, so that needs to get done. Non-standard Parson wires. Think we've done that on the underside. But haven't checked the top side yet. So I'll make a box for that to be done. 19 below relative power strip. I think we just did that. Check D17, it was good. R24, R25, it did not check those resistors. I guess I should. Did resolder it all. So let's should check those resistors, make sure they're the right ones. And go to schematic. When in doubt, read the schematic. Relative power. 88K and a 1K. Let's check those pretty quick. They're not critical. Okay, where are we here? This is the 88K here. And it says 106K. That's 20%, and considering that this is a relative power output meter and you just change the pot to make it say whatever you want, I think that's going to be good enough. We know the diode is okay. It's supposed to be 1K here. think we're reading a meter there. Yeah, we're reading a capacitor. Anyway, freaking 1K resistor. How hard can it be? Yeah, 1K. There we go. Alright, so that's all okay. So we can check that off. Relative power. Where are we? D17, check R2425. That's done. So that's done. 329. Mark that off. Okay. Worked on the power supply. Meter switches, not working on that yet. Antenna relay jack. So we're going to replace a need to do this. Okay, well, I get pretty tired, but so I have to edit this down. This has been running for hours, but that's a pretty good idea of what kind of stuff that you gotta do. Okay, I'm gonna take out this capacitor block with the plater resistors on it. It's all disconnected. So no, where is it? Oh, I know. Trying to find my magnetic gizmo. But, drop anything. So there's just 4 screws that hold this thing, and they look like number 6 screws. Each one's got a little lock washer on it. Don't want to lose that. It's like one of them holds this ALC terminal strip on, and so that's going to be flopping around, and right now it's only got 1 wire soldered to it because I've taken all of the components off it because they were all bad or wrong. Okay, so 1 more of them, and of course it's buried behind this bundle of wires, but hopefully I'm doing this right. And if there is a God, this thing will lift right out of there. It did. And of course it fell apart in my hands because it's just a stupid sandwich. Oh, I'm sorry that happened. It's just a sandwich of capacitors in plastic gizmos. So there it is. That's the whole deal. And then this is the cover that goes over it. We just took the nuts off of these 4 screws, which are captive on this thing. These are called, I don't know, spade screws or some damn thing, but they're riveted to the thing. So that that was simple. And what I want to do is disconnect these capacitors from each other just enough so that I can take my, let's see who made these, very high quality, micro EMF it says, or synchro EMF, 200 microfarad, 450 volts. So these are very high quality capacitors, and they're often replaced unnecessarily. At least in the SP200s they are. And I don't know about these because I've never had this amplifier before. But anyway, the replacement capacitors are these things from Harbach, 330 microfarad at 450 volts. So they're going from 200 to 330. That's a big jump, and it's no wonder that they're then trying to sell you an inrush protection circuit. When you increase the value of the capacitor in an input capacitive input filter, which is what this is, you increase the peak inverse voltage on the diodes and the transformer. So, somewhat ill-advised, if it were me and I could find a value closer to 200, like say 220 or 250, I would use that in preference to, what are these things, 330? I would use that in preference to 330, because what's the point in increasing the peak inverse voltage on the diode board and on the transformer? It's just asking for trouble. It's not going to increase, going to decrease the reliability, and the extra filtering, as far as I know, isn't needed. The thing has enough dynamic range in the power supply to work as a sideband linear amplifier just fine all these years. So, there we go. Plenty of people are using these. I guess it's working okay. They've probably used better diodes and higher voltage, peak inverse voltage diodes in the new Harbach Power Supply board. I certainly hope so. So maybe that eliminates most of the problems. But that's what's being done when you use the Harbach kit. And I'm tired. I'm done for the day.